Hello, friend.
Hello, friend.
Welcome to this live session. In this session, we will try to solve uh, year for the year 2021. Get the question paper for the stream geology and geophysics. So let's start. Starting with the first is the general aptitude. The first question is that multiple choice question. Here the people dash where the demonstration were from the section of society. Which option is it correct? The C option is correct. Who? Why? The people who were the demonstrators were from all section of society. The word who is used to refer to the people in this context. So option C is correct. Now this question is very easy. Here this is a mirror image, asking for the mirror image. When you will put in this direction and your mirror is here, then obviously your C pattern is a correct answer. So answer C is correct. Now the question is for a regular polygon having 10 sides. The interior angles between the sides of the polygon in degrees is 396, 324, 216 and 144. So to find the interior angle of a regular with 10 side, we can use the formula 44. This is the answer. So remember that interior angle n minus 2 multiplied by 180 upon n. Next question is which one of the following numbers is exactly divisible by the 11 power 13 plus 1? For this type of the question, what we will do using property divisibility, option D. So answer. Next question is that which of the following option maintains a similar reaction in the above sentence? Stone, land, water, and mountain. Oasis is what? Oasis is a water body. We have read in geology how the oasis is formed. So answer C is correct. Now come to the geology section. Choice question, carry 1 mark for each other. Which one of the following planet the highest average density? Of course, the highest average density is the Earth, 5.5 gram per cc. So the next question is in a multiple electrode resistivity tomography, that is ERT survey, using equally spaced electrodes, which of the given configuration will provide the maximum number of data points? So the first option is that this one, uh, Venner array, axial dipole array, axial pole dipole array, and Schlumberger array. So one by one, we will see the explanation for this. Venner array. In the Venner array, electrodes are spaced equally and moved systematically. It provides a good resolution for the shallow depth, but typically generates fewer data points compared to the other arrays. So this option cannot uh, be for this question. So next question is the axial dipole array. In this configuration, electrode are arranged in a dipole setup along the survey line. It can provide a high number of data points, but it is still might not be effective as the other array in terms of the maximum the number of data points in some configuration. Option C is the axial pole dipole array. The axial pole dipole array involves keeping one electrode fixed pole while the other is moved along the survey line. This configuration tends to maximize the number of data points collected because it allows for the various combination of measurements at different spacing. So conclusion is that this is the correct answer because the configuration often preferred in ART survey when the goal is to achieve the maximum number of data points, especially with equally split, then axial pole dipole is the correct answer. Schlumberger array in this poles are not placed in equally space. In the Schlumberger array, two inner electrodes are kept close together while the other electrodes are moved further apart. It provides a moderate data resolution and is suitable for both shallow and deep survey, but does not achieve the maximum number of data points compared to the pole configuration. So final is that axial pole dipole array in the ART survey. Remember that, which achieve a maximum point of observation. So the next question is that next question is in electromagnetic methods of prospecting, which one of the given option is correct? Our frequency and type of current source for the primary field used. The high frequency AC, low frequency AC, both high frequency AC and DC, low frequency DC. So we will see the one by one explanation of all these options and try to find out the correct answer. First option is the high frequency AC. High frequency FC waves are generally limited to shallow investigation because they do not penetrate at deeply. High frequency waves are more easily attenuated, weakened by the subsurface material. So this cannot be. The first read the question is carefully. In electromagnetic methods of prospecting, which one of the given option is correct about the frequency and type of current source for the primary field use? That's why option A is not correct, because its attenuation property is high. So low frequency AC, it's a correct answer, because low frequency AC is commonly used in electromagnetic prospecting because it can penetrate deeper into the ground, allowing for a better direction of subsurface structure. This frequency range is deal for mapping and studying in geological formation at depth. So option third is the both high frequency and AC/DC. Direct current DC is not typically used in the electromagnetic method because it does not produce the oscillating magnetic field required to induce sedimentary fields in the ground. Low frequency DC, whether low or high frequency, is unsuitable for EM prospecting as it lacks the oscillating properties needed to create a primary field for electromagnetic induction. So the correct answer B, low frequency AC, is correct. एक्सप्लेनेशन in हिंदी इलेक्ट्रोमैग्नेटिक प्रोस्पेक्टिव ऑफ में लो फ्रिक्वेंसी एसी का उपयोग किया जाता है क्योंकि ये जमीन के अंदर अधिक गहराई तक पहुंच सकता है। ये फ्रिक्वेंसी सब सरफेस में अच्छे से पेनिट्रेट करती है और जियोलॉजिकल फॉर्मेशन का पता लगाने में मदद करती है। सो आंसर इज लो फ्रिक्वेंसी एसी करंट, अल्टरनेट करंट। सो द नेक्स्ट क्वेश्चन इज this one group is a unit of lithostratigraphy, sequence stratigraphy, and biostratigraphy and chronostratigraphy. So explanation of each option is first we will see lithostratigraphy. The correct answer is lithostratigraphy, of course. In lithostratigraphy, a group refers to a collection of related associated rock formation. It is formed unit used to organize and classify layers of rocks that have a similar geological origin or characteristics. Sequence stratigraphy, it cannot be done because sequence stratigraphy division of sedimentary deposit into units based. Or biostratigraphy is the branch of stratigraphy that uses fossil content to define age of rock layers. It does not use group as a unit. Chronostratigraphy focuses on the age of the time relationship of the rock strata, establishing a logical framework for stratified rocks. Group is not used as a formal unit in a chronostratigraphy. So the correct answer is a lithostratigraphy. Now the question number 5 is a Forensian is an epoch of Cambrian, Ordovician, Triassic, and Cretaceous. Of course, this question is so tricky because when you will remember everything in a stratigraphy, then you will can do. So the correct answer, we will not go in the deep. The correct answer is A in the Cambrian. Why? The Forensian epoch is the last epoch of the Cambrian period. It represents the time period from the 497 million to 485.4 million years ago. The Cambrian period is known for the Cambrian explosion, a time of the period of diversification of life. That's why it is asking for the in this question. So the next question is the stage of textural maturity of a clay sandstone containing a poorly sorted and angular framework grain is mature and the super mature, immature, and submature. So this is a very important topic in the sedimentology. So one by one we will see the each option and try to find out the correct option. So immature sandstone, what is meaning of this? Contain high amount of clay, is poorly sorted and has a angular grains. This indicates that the sediments has mature sandstone. He has a well sorted rounded grains with little or no clay content, indicating extensive transportation and weathering. High in a super mature sandstone, high amount of clay, is poorly sorted and has a angular grains that indicate the sediment has not undergone extensive transportation. Next is which one of the following structure indicates a sedimentary deformation? Bedding and this one is flasher bedding, tabular bedding, and convolute bedding. So explanation: sedimentary deformation, you know well what is it is application of the stress and strain, that is called in sedimentary deformation. Any deformation occurred due to the application of that is called the deformation. So, in what happened in the convolute bedding, it is a structure that indicates a sedimentary after deposition. So, of course, the convolute bedding is the correct answer for this because it is indicating since sedimentary deformation. It means it is not a typically associated with sediments deposition in a following water environment, but does not indicate sedimentary deformation. Flasher bedding is a sedimentary structure found in environment with deformation. Tabular bedding deposition and does not sin sedimentary deformation. Convoluted bedding after deposition, often due to a, that's why the sin sedimentary, often due to a slumping of water escape. SP log, a spontaneous potential log. So in this question, low value in SP log as observed at dispersed cells in mainly due to the dispersed cell are intended movement of Cl ions rather than Na plus ion. In cells, the movement of chloride ions is low probability and high clay content, which impact the SP responses uh, by reducing to electrical potential. First option is sodium ion. While sodium ions are present in the cell with high clay content and reading, and the potassium ions are less influential in the SP responses and are the not primarily responsible for the मुख्य कारण मूवमेंट में रुकावट होती है जो सेल्स में आयंस की मूवमेंट को कम हो जाती है क्योंकि उसमें क्ले कंटेंट. The next question is in a radiometric survey, the gamma target rock volume, solid angle of the target rock about the spectrometer. Option C of each option. Crack present in the target rock volume. Uh, the first is cracks in the target rock do not directly affect the ray spectrometer count rate. While they may influence integrity or structure, they do not impact the count rate of the gamma ray depicted by the spectrometer. Solid angle of the target rock about the spectrometer. This is the correct answer because in radiometer survey, when the gamma ray spectrum count rate depends on the count rate depends on the solid angle as it determines how emitted gamma radiation from the rock reach the detectors. A larger solid angle would mean more gamma ray are detected, increasing the count rate. This is a key factor in radiometric survey. So solid angle of the target rock about the spectrometer is a key. So solid angle must be remembered. Temperature in the target rock. Temperature does not directly affect the gamma ray count rate in the spectrometer. Pressure in the target rock. Pressure in the target rock also does not have a significant impact on the gamma ray spectrometer count rate. So if we will see explanation for the option B, रेडियोमेट्रिक सर्वे में गामा रे का काउंट रेट उस सॉलिड एंगल पर निर्भर करता है जो टारगेट रॉक और स्पेक्ट्रोमीटर के बीच में बनता है। यह एंगल निर्धारित करता है कि रॉक में एमिट हुए गामा रेस में कितने स्पेक्ट्रोमीटर तक पहुंचते हैं। इसलिए करेक्ट ऑप्शन इज बी। Now the question number 10, the dimension of radiant emittance of a black body as per Stephen Boltzmann law is. So these are the A, B, C options. The if you know about the Stephen Boltzmann law formula, then you can do easily. The Boltzmann law state that the radiant emittance E energy per unit time of a black body is proportional to the force power of its temperature. E is equal to the formula. Energy is the dimension of what? Energy, energy is the unit of the joule. So energy of ml is the dimension of ml square and t square. So next is since radiant emittance in the energy per unit area per time as divided by the L square, and by t is the time. So dimension of E ml square t square upon L square t. So finally this will escape glacial valley. The process involves the removal and the transportation of rock by the pi square minus 4 by 3 beta square is equal to the bulk modulus, mu the shear modulus, and rho is the density. So first things about these options, and then we continue to the next things about this option for 1 minute and 1 to 2 minutes. And come to the explanation. In this question, we are given alpha p wave velocity, beta s wave velocity, k is the bulk modulus, and rho is the density. We are asked to find the expression of alpha square minus 4 by 3 beta square. Formula for p and s wave velocity is p wave velocity is alpha is equal to under root k plus 4 by 3 mu upon rho, and s wave velocity is equal to under root mu upon 4. So next what will you do? We will combine this formula, then do the mathematics term, then we find that the correct answer alpha a is equal to, first remember that these two formula, then you can easily do, then k by rho is the correct answer. Now, question number 14. In a reduction of the gravity data, the latitude correction is the maximum at 35 degree, 45 degree, and 55 degree, 65 degree latitude. Explanation: the correction is based on the formula that incorporates cosines of the latitude angle, and the change in gravity due to latitude is most pronounced around the mid latitude, specifically around 45 degree. Beyond this latitude, the rate of change begins to decrease as one approaches the poles. So thus the latitude correction is additional data में latitude correction अर्थ के और उसके रोटेशन के लैटिट्यूड के साथ उसमें डिपेंड करता है। सो ये मैक्सिमम जो होता है 45 डिग्री, क्योंकि फार्मूला भी यही होता है, फार्मूला कॉस स्क्वायर लैम्डा होता है। So 45 degree is the correct answer. So the most coalescence unit of the Gondwana supergroup is Talcher formation, Barakar formation, Karharbari formation, and Panchet formation. The first is Talcher formation. Let's see this is correct or not. The Talcher formation is the oldest unit of the Gondwana group, primarily consisting of a glacial deposit, but is not rich in the coal. Okay, in this formation we will found the T-lite, Lite. It's a glacial. If we found the T-loid D, then it's a not a glacial origin. So Barakar formation, correct answer. The answer B is why this is the correct. The Barakar formation is known for its significant coal deposits and is the most coal rich formation with the Gondwana supergroup. This formation is the main source of coal many Indian coal fields. So option B is the correct. Karharbari formation, why Karharbari formation is not correct? The Karharbari formation also contains a coal, but it is not extensive or economically significant as the Barakar formation, so it is not correct. Panchet formation, the Panchet formation primarily consists of the non-caloriferous sedimentary deposit and does not contain substantial coal reserves. So the correct answer is the Brakar formation. और ब्राकर फॉर्मेशन गोंडवाना सुपर ग्रुप का सबसे बड़ा कोल रिच यूनिट माना जाता है। इसमें कोयले के बहुत ही ज़्यादा डिपॉजिट्स हैं। Next question number 16 to 25, numerical answer type question, carry one mark each and no negative mark. So numerically we will try to solve this, and I'm इसे मैंने जानबूझ के हिंदी में लिखने की कोशिश की है ताकि ज़्यादा से ज़्यादा लोगों तक पहुंच सके, क्योंकि हर कोई इंग्लिश मीडियम में नहीं पढ़ता है। A vertical borehole encounters a shale bed of uniform thickness occurring at a depth of 5 meter and dipping at 60 degree. The borehole pierces through this shale bed for a length of 10 meter to reach sandstone layer below. The true thickness of the shale bed is, ये पूछ रहा है, तो इस क्वेश्चन में क्या दिया है? एक वर्टिकल बोरहोल दिया हुआ है जो सेल से होकर सैंड लेयर तक पहुंचता है। यह सेल बेड के साथ 60 डिग्री के एंगल पे डिपिंग करता है, एंगल बनाता है। बोर जो लंबाई सेल बेड की ट्रू थिकनेस में दिखाई गई है, उसके आधार पे हमें इसकी ट्रू थिकनेस निकालना है। तो ट्रू लेयर टिल्ट रहती है तो बोरहोल में मापी हुई लंबाई 10 मीटर और ट्रू थिकनेस में फर्क होता है। इस फर्क को निकालने के लिए ट्रिग्नोमेट्री यूज करते हैं हम। फार्मूला ट्रू थिकनेस फॉर T इक्वल टू L cos theta, where L is a 10 meter, it has given, theta is 60 degree, it has already given. So true formula T is equal to T L into cos theta, and put the value inside this, and for cos 60 degree you know 0.5 1 half, and put this inside the true thickness is a 5 meter. So सेल बेड की जो ट्रू थिकनेस है वो 5 मीटर में है। और इसको बहुत ही सिंपल समझें, जब एक परत झुकी हुई थी मतलब टिल्ट रहती है तो बोरहोल की लंबाई जो उसकी एक्चुअल थिकनेस है उससे ज़्यादा होती है, और हम 60 cos 60 डिग्री का एंगल दिया हुआ है, उस झुकी हुई परत की असली मोटाई पता कर सकते हैं सिंपल ट्रिग्नोमेट्री से। सो यूज दिस फार्मूला, एंड when you can also derive this formula with the help of the rectangle triangle. Question number 17. The mass and volume of a fully dried soil samples are 20 200 gram and 1100 cubic centimeter respectively. If the specific gravity of the soil particles is 2.5 and water density is a 1 gram per cubic centimeter, the void ratio of the soil is. So let's try to solve this numerical. To find the void ratio E of the soil, we can use the formula E is equal to G gamma W upon gamma D minus 1, where when you will find the density of the soil and density of the water is given, then you will use this formula, or specific gravity is introduced in this. So specific gravity of soil is at 2.5 has given. Gamma W density of water is 1 gram per cc has given, and gamma D dried density of the soil in this. So the void ratio of the soil we have to calculate. The first step, calculate the dry density. The dry density gamma D can be calculated using the mass and volume of the soil sample. Mass of the soil and volume of the soil. Mass of the soil in this, and volume of the soil is this. In starting, it has given. So gamma D is a 2 gram per centimeter cube. This is a dry density. Now, step 2. Now we can substitute the values into the void ratio formula. So void ratio formula is this, and we have calculated gamma D. So put this value in this, and finally we found out the 0.25, and rounded this, then rounded to two decimal, then we will find the 0.25. This is the correct answer. So remember the formula E is equal to G into gamma W upon gamma D minus 1, and for dry density, mass of the soil in the volume of the soil. Next question is question number 18. A constant head permeability test was performed on a vertical sand column of a height is 40 centimeter and cross sectional area of 25 centimeter square. During the test, when the loss of head was 50 centimeter, the volume of water collected in 2 minutes was 300 cubic centimeter. Applying Darcy's law, the calculated coefficient of permeability of the sand column is this. Uh, so we have to calculate the this permeability, coefficient of permeability. So for this, we have given height of the sand column is a 40 centimeter. When you read the question very carefully, cross sectional area 25 square centimeter, head loss is 50 centimeter, volume water collected q is equal to 300 centimeter cube cubic in 2 minutes, which is 120 second. When you will convert in the second per second, then find it very simple. This is to 120 2 minutes means this is 60 multiplied by 2, 120 second. सो फार्मूला अकॉर्डिंग टू डॉर्सी लॉ जो कि परमेबिलिटी टेस्ट में इस्तेमाल होता है, वी कैन फाइंड द परमेबिलिटी कोफिशिएंट के विद द फार्मूला. सो के इज इक्वल टू q into L upon A into H into T, where q volume of water collected, L is the height of the sand column, A is the cross sectional area of the column, H is the head loss, T is the time taken to collect water in seconds. So step by step that's why I have converted to 2 in the 120 second, because here must be it in a second. Convert times into second we have already done. Substitute the value into the formula. K is this. Calculate the number, and finally for k is equal to 0.08 centimeter per second. The coefficient of permeability of the sand column is 0.08 centimeter per second. It's a right answer for this. Now next question is, the next question is the radius r of oblate spheroid at 45 degree latitude with ellipticity of polar flattering of 1 upon 298.25 and equatorial radius of 63781 40 meter is. So this, think about this question. So pro- uh, polar flattening is given and latitude is given, equatorial radius is given. So we have to calculate the radius of the oblate spheroid and this, and the equatorial radius in this. So the first we will see the what the given in the question. So the first given information in the question, the equatorial radius, polar flattening 1 upon this, and the latitude is lambda value is 45 degree. The radius we need to 45 degree latitude, so we will calculate the radius of the earth at a specific angle. Step by step solution we will see. Calculate the flattening factor f. So simplify this 1 upon, because flattening factor f is equal to in converted in the decimal, because it is given in the fraction. Now next is that find the polar radius b. Using the equatorial radius and flattening f, we can calculate the polar radius, which is slightly smaller than the equatorial radius, because earth is not a perfect sphere. So b is equal to a multiplied by 1 minus f. F we have calculated, and a is given, that is the this is the equatorial radius which is given here 632. So polar radius is b is equal to this 1 minus this, and finally we got this. Okay, now equatorial radius we have polar radius. So use the radius of radius formula for an oblate spheroid. So for oblate spheroid, the radius formula is r is equal to in Square root a square cos square phi plus b square sin square phi upon cos square phi plus sin square phi. Remember that very easy formula. R is equal to under root a and b. Remember cos square phi, and all in trigonometry all is r square and in square root. So a square cos square phi plus b square sin square phi upon cos square phi plus sin square phi. Put this value in this inside. We have calculated, and we know the cos 45 degree is this, and sin 45 degree, what the value of sin 45 you know well. For both of these, 1 upon root 3 by 2. Okay, after putting this value, the final answer is uh, calculating each part and put this value, the final answer we will got this r is equal to 6367.45. This is the correct answer. So the remember that radius formula for an oblate spheroid is this. So you, I think you can do remember, and this is the final answer. Now next question we will see. The next question is that the water table is an unconfined aquifer at a place near the coast is 1 meter above the mean sea level. Given the densities of fresh and saline water as 1.001 and the 1.025 gram per cc respectively, the fresh saline water interface at the same location should be at the depth of meter from the water table. This is question. Now first we will try to understand the what questions are uh, telling. The first is that this question is about the finding the depth of the fresh saline water interface in an unconfined aquifer near the coast where the water table is 1 meter above mean sea level. Given formula: water table height 1 meter above mean sea level, density of fresh water is a 1.001 gram per cc, density of saline water 1.025 gram per cc. These are the given. So explanation of in simple word: in coastal areas, fresh water and saline salt water from layers underground. Fresh water being lighter sits above the saline water. The depth at which these two types of the water meets is known as the fresh saline water interface. To find this depth, we use a concept called the Gahaban-Herzberg principle. According to the principle, depth of interface below water table, density of saline water upon difference in density is multiplied by height of the water table. So remember, when this type of the water is mixed, then there's a principle is what that principle name is that Gahaban-Herzberg principle. Okay, so depth of and the formula is for this: density of depth of interface below water table is equal to density of saline water upon difference in densities multiplied by height of water table. So put the value in this formula: density difference which are given for the water and this calculate the depth of the interface. Here the using the formula 0.03, and density of saline water is 1.025 and multiplied by 1. This is the height of the water table here given 1 meter above mean sea level. So the final answer is the 42.7 meter is the right answer. The fresh saline water interface should be at the depth of 42.7 meter from the above water table. Now the next question is that the volume percentage of galena and quartz is in a ore body of lead are 90 and 10 respectively. The densities of galena and quartz are 7.6 and 2.65 gram per cc respectively. The grade of the ore body in terms of the weight percent of the Pb is, and the atomic weight of the Pb is 206, and sulfur for sulfur is 32. So we will try to understand this question and read this question carefully. I will explain it within 1 minute.